So let's look at the algebra tiles. There's three different sizes that you have. So do you see how you have the big square, and then you have like the rectangle, the skinny rectangle there, and then you have like the tiny little one? Okay. And so they're blue, green, and like, I don't know, off-white, yellowish, whatever you want to call that. If you, yeah, cream, we'll go cream, I guess, I don't know, like yellowish. Do you see how if you flip them over, the only option is red? Like they're all red on the other side. Okay, so we're gonna put what that means in the key here. And it is always important to read the key so that you know what everything stands for, okay? Now you don't wanna write huge or else it won't all fit in here. The big square, so like the big blue one, represents x squared. And what I'm gonna do is color in, if it's the red side, that would be negative x squared. And I'm sorry, I went out. After I just told you don't write too big or it won't fit, I wrote too big and mine didn't fit, but I want to write big enough so you can all see it. Like your notes are kind of different from what I do because I'm doing it in front of a whole room full of people that I'm trying to explain it to. So I try to write like a little bit bigger. So this is a positive x squared. And if you flip it over, that represents negative x squared. None of the problems on these notes actually have an x squared, so we won't use the big square ones today, but that is what they mean. All right, so then the like skinny rectangle one represents just an x. And then same thing, if you just color it in, that represents the red side, and that would be negative x. So we got an x squared, we got an x, and then the little square just represents 1. And so the red side, which I'm going to fill that in, would be negative 1. So that's what they all represent. And again, we won't have any of this big squares in this. There's not any x squareds like on these notes. So what we want to do is represent these expressions using the algebra tiles, and then we're just going to draw it on the paper. I'm not grading your art skills. This is like do your best, okay? So 3x minus 2. Let's start with this 3x. It's a positive 3x. So you would want 3 of these. That's 3 x's. So you'd want to pull out 3 of those. And then we want to subtract 2. So you would need 2 of the little squares, but we want to subtract them. So just flip them over. So we have positive 3x and then minus 2. So negative 2. Is everybody still with me? That's what you're going to draw in this little box. That's the representation of that expression using the algebra tiles. So we have 3x. And if you draw your rectangles sideways, totally fine. It does not make a difference. However you do it is fine. And that's the answer to the question. That's all it is can you represent it with the tiles? That's all. So for that one, we had 3 x's and then minus 2. This one is 3 times the quantity x minus 2. So let me just cover up the 3 real quick. How would you represent just the x minus 2? Go ahead and with your partner, do x minus 2. Like pull out the tiles for just the x minus 2. So what did you use? And then like 2 red little ones. So this would be 1x minus 2. Okay, now you want 3 of those. So this is an x minus 2. And then here's another x minus 2. And then here's another x minus 2. So we want 3 of that amount. Does that make sense? Okay, you can draw them in whatever order or mashup you want on there. It doesn't matter. You can draw them like the way I have them here. If you want to like group all of the x's together and then all the negative ones, you can do that. But you're just going to draw that in this little space here. Did you have a question? Okay. All right, so just draw that in here. And again, you can draw them sideways, you can draw them upright. It is not going to make a difference. You can draw them grouped however you want. And so from looking at your picture there, what's another way we could write that expression without parentheses in it? Like just looking at this you have right here, how could you write that? I guess what I'm asking is how many x's do we have? 3. So you could say 3x, and then these are colored in, so they're negative. So it's subtracting 6, so minus 6. So 3x minus 6 is another way you can write that. They mean the same thing, they're equivalent. And what we did is distribute the 3. We're going to practice that like on the back side of this paper. Do you remember distributing? Is that something you've done before? We're just doing it with the algebra tiles. If you don't remember it, that's fine. I'm going to go over it. All right, so what I want you to try and do with your partner is represent this with the tiles. And part of it is the same as what we just did. So there's only like one extra thing that you're going to have to put in there. But I want you to try and represent this with the tiles.
-2.
You ready to do it?
And then
Yeah, so that part is the same as what we had up here. You're just going to have to include a -2x to it. There you go. So, and I see some of you drawn it already. So this is what we had before. That's the 3 parentheses x minus 2. You just need to include a -2x. So how did you do that? What represents the -2x? Like what tiles are going to be for the -2? The red rectangles, 2 of them, right? So this will be a -2x. So this is what you're going to draw in that little box. And again, in whatever order you want, you can draw them sideways or upright. It doesn't matter, but that's what you're going to draw to represent that. This is the -2x, and then this is the 3 quantity of the x minus 2. So then there's another box there, draw the simplified expression. So what we want to kind of add to our notes here is, and you can sort of write it underneath the key, what we call 0 pairs cancel out, or they undo each other. But if you have a positive of something and a negative of something, they're going to undo each other or cancel out. So what you want to do is look through there and find 0 pairs. So a pair that will undo each other. So do you see any on here where that's going to happen? Like things that we can cross out because they're going to just undo each other. A -x and what? Positive x. Good. Do you see how those two are going to cancel out? Here, you know what? I'll use a different color for this. So cross out a -x and a positive x. And then what else? Yeah, like we can do another one, right? Another -x and another positive x. So those are gone. Is there anything else? I think that might be it. So we're going to draw the simplified expression over here. So what's left, like that we didn't cross out? An x, good, and then -6. And so that would be x minus 6. So that's simplifying it with the tiles. You just cross them out. So 0 pairs cancel out. So you find a pair that's the same thing, but one positive and one negative, and they're gonna undo each other, so they go away. I love these cute little doodles. We're just like doodling in math class. Fun, it gives you something to play with here. All right, so this next one, it's the exact same thing again. Do you see the negative 2x plus 3 parentheses x minus 2? All that part is the same, so get that back out. And then what you want to do is just add 4. So with your partner, go ahead and represent that. You want basically all the same thing that you just had. Here's the negative 2x, and then the 3 quantity of the x minus 2. So that's what we had before, and then you just want to add 4. So what would I include on this to just add 4? Like, they're not green, but yeah, I knew what you meant. Like not red, like the other side. So 4 of the, well, you know what? I'm going to call them yellow for lack of a better word. We'll say they're yellow. It's like a pale yellow, but that's all right. So we're going to go ahead and draw that. I know you're all super excited. That's getting to be a lot of things. Don't worry, that's the biggest one we're doing. But go ahead and draw that in the little box. You'll have to like kind of write small. But if you don't draw it, I know you're probably like, we have to draw all of this. If you don't draw it, you're not going to be able to like see what X is out. So, so just do it. I'll give you a pep talk. Go team, you can do it. Just draw all the little boxes. You'll be fine. Yeah, I ran out of room for the positive 4. So what is going to 0 out? What can we X out here? All right, so 4 of the red ones, and then 4 of the positive ones. So those are gone. We had 4 positives and 4 negatives, and then what else? There we go. So 2 positive rectangles, 2 negative rectangles. That's 2x and negative 2x. And then for the little squares, we had a positive 4 and a negative 4. So what's left in that gigantic mess there? You kind of have to sift through it. What do we still have? Good. 1 positive rectangle, which is x. Good. And then minus 2. Good. Nice job, guys. So it is x minus 2. Cool. It feels like you guys got that. We got one more, and then we'll do a break. So just like up here, when I covered up the 3, I said just represent the x minus 2, and then we'll do 3 of them. Let's do the same thing here. Represent x minus 2. With your partner, just pull out an x minus 2. So here's an x, and then you would need 2 of the red squares for minus 2. Did we all agree that's x minus 2? Okay, don't look away. Look up here. Watch. Here's what's going to happen. That's the x minus 2. If you want to negate that, you just flip all of them over. So the whole thing gets negated, or like it's opposite of what it was before. All right, so we're going to have a red rectangle, and then the 2 squares are positive. And so what is this simplified expression like that represents? Good, negative x plus 2. The whole thing is opposite of what it was before. So go ahead and flip over. I'm going to give you a 3-minute break here, and then we'll do this next page. So we did the simplifying using the tiles. So you kind of just see it visually and then like X out what cancels out. Now we're going to simplify expressions without the tiles. So you don't have that like visual anymore, which makes it a little bit tougher. Okay, so we can do it without the algebra tile. So on this side, we're going to do combining like terms. So first we're going to talk about, you know, like what like terms are. So when you look at these two, are they like terms, yes or no? Like, do you think they are? Like, what is your instinct? Good, the answer is no. And why not? Because they aren't, you're correct. Yeah, it's not the same variable. One's an X and one's a Y. It's like apples and oranges. You're not going to be able to add them together like that. All right, how about number 2? Are those like terms? Yes, they both have a y squared. And then how about 4a and negative 3a squared? No. So they both have an a, but the problem is one is squared and one is not, so that doesn't count as the same thing. So that's going to be no. So if you can combine them, then you should. So to combine like terms, you're going to add or subtract whatever the problem says, the coefficients. And that's a like math vocabulary word, so let's talk about that. When I say coefficients, what does that mean? Like what part of the whole thing is the coefficient? Like when you're looking at 3x, the coefficient would be what? 3. The variable is x. So that's the vocabulary there. So the coefficient is just a fancy word that means the number that's there. Do you know what I mean? Like we try to complicate everything in math class. It's just a fancy word that means the number that it's how many of them you have. You have 3 x's and you have 5 y's. Okay, so let's do this one since we can combine these together. Still going to be y squared. That's the most common mistake is people change the y squared. That part's going to stay the same. You're just going to add or subtract the coefficients. So negative 2 plus 5. 3, good. Or you could think of it as 5 minus 2. So it would be 3y squared to combine those together. I always tell everybody to think of money. It's like if you owe someone $2, but then you get $5. Like you would pay the 2 that you owe and then you'd still have 3. You guys will be allowed a calculator for everything. I just feel like for these, we'll just talk our way through it because you don't have to like get out your Chromebook and then I'd have to like walk around and make sure you're all on the correct screen and everything. So we'll just talk our way through it. But like on a test, you're always going to be allowed a calculator. You could type in negative 2 plus 5 always. Okay. So let's go and combine these if we can. If we can't, then we just won't be able to do anything. 4x minus 6x. So first of all, do those go together? Yes, they're both just x. So they are like terms. And it's still going to stay x. You're just going to do 4 minus 6. It will be a negative result. Negative 2x, perfect. And think of it like money. Everybody understands money. Like you have $4 and you owe someone $6. So you give them the 4 you have and then you still owe them 2. All right, how about this one? What do you think? 4r plus 4y minus 8. Yeah, is that what you're gonna say? I'm sorry, you actually raised your hand. We can't do anything with that. None of them are like terms, so that is just the answer. Yeah, if you can't do anything, then don't do anything. That's just don't meddle with it. We love no work, right? No work is the best, so just don't do anything. All right, 4g plus 6g minus 3g. Those will all go together. Yes, sir. Yeah, good, because 4 plus 6 would be 10, and then minus 3 would be 7, so 7g. Sounds like we're talking about like, you know, like the phone networks or whatever, like 4G or whatever. All right, down here, this one's a little bit tricky because they don't all go together. Only 2 of them will. Which 2 will go together? Yeah, perfect. The negative 7y is just there. It is just there. You'll just tack it on at the end. It's like along for the ride. Okay, we're only going to combine these. So 13x plus 4x. Good, that'll be 17x, and then the minus 7y is just there. That is literally it. It just stays. So if you can combine it, do that. If not, then just do nothing. All right, and then over here, only 2 of them are going to go together. Which 2? Yep, the 5x and 4x, that will make 9x, and the rest of it you just have to copy down. Minus 6 plus 5x squared. So you just add or subtract the coefficients. And again, these were all kind of small-ish numbers, but if you ever get hung up on negatives or like, again, you will always be allowed a calculator on quiz or test, always, okay? All right, now here we're going to do the distributive property, and that's for when you have parentheses. So if you have a coefficient out front of your parentheses, you take whatever that is and distribute it. It just means multiply it to each of the numbers in the parentheses, okay? And then if you have any like terms, you would combine them together. So it's distribute first, then combine any like terms that you have. So for example, here, you would take this 3 and multiply it to each of the terms inside. You don't have to draw the little rainbows unless you want to. Most people do just to like keep track of it. but you're just going to multiply those by 3. So 3 times 2x. It will be 6x, perfect. The variable is kind of like just there. And then minus 3 times 4 be 12. That is it. And again, you will always be allowed to calculate. Here we're going to take the negative 3 and multiply it through. So negative 3 times 4x. Negative 12x, perfect. And then what about this one? Negative 3 times negative 6. Good, the negatives cancel out, so it'll be plus 18. So negative 3 times negative 6 will be positive 8. This one, you can rewrite it if you want. Here's my suggestion, because the negative out front tends to like bother people. If you write it as a negative 1 instead, sometimes that helps. If you don't want to do that, fine, like personal preference, or some people will just opposite. Remember we did that with the tiles just a few minutes ago? We just flipped them all over. It's just going to negate what's inside of there. But if you distribute a negative 1 through there, what are you going to get? Stop that while I'm teaching. Put it under the desk. It will be a minus 4, but the first term will be what? Yeah, positive 2x. So 2x minus 4. So everything's just going to opposite. This one's a little tricky because the 5 got put at the end, but it's literally the exact same thing. You're just going to take the 5 and multiply it to everything in the parentheses. So negative 2x times 5. Be negative 10x plus 20 times 5. Does anyone know that? I'll tell you. If not, it'll be 100. Good. Like if you have 5 $20 bills, you'd have $100. And you could take us all out to lunch. All right, so now these ones we're going to have to distribute first, then combine like terms. Actually, let's put that in here. Distribute first. And then you're going to combine like terms. Your notes are for you to look back at when you get stuck on something else. So like the idea is you want to write down what's going to help you. So distribute first, then combine the like terms, because you need to do what's in the parentheses first. So for this first one, we're going to take the negative 5 and multiply it through there. And again, sometimes when it's not an X that bothers people, this one's an A, it's fine. It's just a different letter of the alphabet. That's all. So if you distribute the negative 5, what is that going to give you? For the A. Good, negative 5A. And then when we go to the second part, so it would be negative 5 times negative 6. Good, plus 30, because the negatives are going to cancel. This plus 2A is literally just there. It's just there. You just have to write it down as well. So we distributed, yay us. Now we're going to combine like terms. So the A's will go together. The plus 30 is just there, okay? Negative 5A plus 2A, negative 3A, good, and then plus 30. So distribute first, then combine the like stuff together. So we're gonna have to distribute twice in this one because there's 2 parentheses, okay? Let's just do the first one. If you distribute the negative 5 into there, negative 5x, perfect, beautiful. And then negative 5 times 2, it'll be minus 10, good, because that negative is going to get multiplied in there. So negative 5 times 2 would be negative 10. So we did the first one. Then you're going to distribute this positive 5 into those parentheses. That'll be 5x minus 25. Beautiful. Yeah, now we're going to combine the like terms together. So it's distribute first, then combine like terms. This one's a little bit weird because do you notice what's going to happen with it? Yeah, like these are going to go away, the negative 5 and the positive 5. So we have a negative 10 and a negative 25. So it's like you owe someone $10 and then you owe them another $25. I don't know what happened. You made a bad bet there or something, but now you're in the hole 35. So negative 35. All right, let's see how it went. When you distributed the 11, what did you put? 88R, good, plus 33, perfect. Now this one's a little tricky because you have to distribute a -2. So that negative has to come with you. Good, oh, nice, plus 18, minus 12R, awesome. Negatives are the most commonly missed thing ever. Like I teach all levels, like I have pre-calculus and AP calculus. I'll tell you negative signs are the most missed thing ever. So just be careful with them. All right, so then let's see what we can put together. We have 88R minus 12R. So 76R, you guys rock. And then 33 plus 18, what is that going to be? 51? Yeah, good, I agree. Nice, that went really well. We'll do another 3-minute break and then we'll do the last page. Okay, go ahead and put the fence back in your backpack. We're gonna flip over to the last page. Oh, I'm hearing you be kind to each other. That's nice. All right, here is where we're going to take like a real world situation and put it into symbols. It's not really any different from what we did last time. Do you remember how we took words and translated into symbols? Like we did those translations. Remember how I did that Jamboard and y'all said why it was important and a lot of you brought up word problems? It's the exact same thing. There's just like a story attached to it. That's all. Okay. So, yeah, like stuff like that. Okay, except there's like a story surrounding it. So first, let's talk about the difference between an expression versus an equation. So an expression has no equal sign. It's just an expression. That's it. It's just blah, 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 blah. An equation is going to have an equal sign. So like I wrote no there, so I'm going to write yes, equal sign. The way you can tell is an equation is going to have an equal sign. So it's going to be blah, 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 equals something. So it's almost like you finished the sentence, like it's going to be equal to something else. So we're going to define the variable. I would usually use X and Y. You can pick whatever letter you want. I would stay away from things like S because it can look like a 5 or L because it can look like a 1. But it is totally up to you. But you're going to define the variable. I'm going to just use X. I think that's easiest. And then write the expression or equation to represent it. So it's just like our translations, right? The bill at Buffalo Wild Wings was split evenly 4 ways. Okay, so you actually already said what it was. It's going to be X divided by 4. Like you're taking the bill and splitting it 4 ways, but you have to define what X is. So what does X represent in that situation? Yeah, like the bill, right? Like the total bill, the total cost. You're taking that and dividing it 4 ways. So like you're splitting it between you and your friends, which is actually not super fair because someone might have gotten something really expensive and someone else might have just gotten a glass of water and then you split it 4 ways. And but I don't know. Depends on how close you are with your. Be like, hey, Venmo me the rest of that. All right, as a heads up, this one's gonna have 2 different variables. So we're gonna need like an X and a Y. Oh, question? Okay, well, hold on. Let me at least read it to everybody. Mechanicsville High School's total points earned during a girls' volleyball match is 5 more than so we won. 5 more than the points that Atlee earned. You're gonna need 2 different variables because there's 2 different teams. Let's just call them X and Y. So let's let X equal MHS points, and let's let Y equal Atlee's points. It's really important to define those, kind of like the key on the algebra tiles that we did, because otherwise you start throwing these variables in there, no one knows what you're talking about. So you have to say what they represent. So then how would you represent the expression? Go ahead. Good. That is what put the equal sign in there. So this one is an equation. So MHS points, that was X, that is 5 more than what Atlee got. So whatever they got, we got 5 more. We won, so we're awesome. All right, Mrs. Lane has to park her car in downtown Richmond in a parking garage. It costs $10 to park and then $2 for each additional hour, okay? So X is gonna be what in this situation? Yeah, the hours, how many hours she parked. You pay based on how long you parked there. I know you guys don't drive yet, but you know how like the costs work, or like it's kind of like putting quarters in a meter. It's just this is way more expensive because everything costs more now. All right, so it would be $10 to park. Like first of all, like you just pay that plus good 2x, $2 for each additional hour. You're really good at this. Word problems can be tough. I feel like a lot of people get scared by word problems and then like just don't even want to read it. Like I feel like that's what happens. So you just got to like calm down enough to like just read through it and see what's going on. Or oh, this is a part B. So we're following along with Miss Lane here. Yes. So you have, oh my gosh, that's so good. So you have a variable that depends on another variable. So the independent one is the one you like plug in for. And then the other depends on what that is. So like how much she pays depends on how long she's there. That's so cool you brought that up. All right. If she keeps her car parked for 5 hours, how much will she spend? Well, you're gonna take 5. Let me just get everybody there. You're awesome. You're gonna take 5 and plug it in for X. That's the number of hours. So 5 times 2 would be 10. And then plus the other 10 that she had to pay to like even get in the garage would be $20. Do you feel like that's a fair price? $20 to park for 5 hours? I feel like that's okay. Right. Would you ever try to go to Virginia Beach at like peak hours and it's like absolutely ridiculous?